research and discovery. Futurists.
In the mining area around Katowice in southern Poland, thousands of tons of coal are still dug out of the ground every year. But this mine hides a secret. 20 meters underground, it's scientists and not miners who are at the coal face, and they have a challenging dream.
This is a coal mine, but we are not here to extract coal. This is an experimental pit, and we're here to assess if there is an alternative way to get energy out of this mine. If, for instance, you inject oxygen and steam into the coal, you can produce hydrogen. The resulting hydrogen can be sent to the surface to produce energy in gas turbines, heat in boilers, or it can be used as a fuel for chemical synthesis.
It's early morning, and a tanker loaded with liquid oxygen has been positioned above ground. It's an experiment that's part of a European Union research project called HUGE. But their goal of producing hydrogen from the colliery is complex and risky.
We release liquid oxygen from this tank to a special secured pool where it expands and turns into oxygen gas. Then we open the control valves to allow the gas to flow, continuously monitoring the rate. We then direct the gas flow to the coal deposit and wait for the gasification process to start.
The entire operation is monitored from this building. Underground cameras and sensors help researchers keep tabs on any possible problems.
This is the heart of the experiment's control system. We control both the gasification process itself and the quality of the air down in the mine. The monitoring is a key element in our research. During underground gasification of the coal, many dangerous and explosive gases are produced. Our monitoring allows us to prevent explosions and leakage of dangerous gases.
Chemists and geologists also keep a close eye on the soil above. Although the mine entrance was carefully sealed, researchers are concerned that some gases could escape through porous layers of soil.
The gasification process is going on 25 meters below us. We use a geo-radar to monitor what's happening in the earth above the pit. It allows us to measure any changes in the underground structure of the cavity where gasification is taking place. We also monitor any possible leakage and analyze the nature of those gases.
Liège in Belgium is another European city at the heart of the coal mining industry. Scientists there carried out several studies to prepare for the full-scale Polish experiment. A reactor inside this giant laboratory helped scientists to partially unveil the mysteries behind coal gasification. The first step was to simulate the interior of a coal mine. They mixed up lumps of Polish coal with an inert material.
This element allows us to simulate the presence of neutral material, because in the gasification process, using seams of coal underground, there's obviously not just coal there. There's also inert material, and we have to be able to simulate that in our reactor.
In the reactor, the resulting mixture was injected with different gases at varying temperatures and pressures. Researchers wanted to understand how coal reacts under different conditions.
Controlling these parameters allows us, if you like, to control the quantity and quality of what comes out of our gasification reactor. For example, raising the pressure will produce more methane. Raising the temperature will produce more hydrogen and carbon monoxide.
They used sophisticated techniques like chromatography to measure and analyze the resulting gases. And a visual inspection of the gasified coal helped the scientists to reach some preliminary conclusions.
There are
three types of gasification. Gasification in the presence of carbon dioxide, which in general terms will produce a gas rich in carbon monoxide. Gasification in the presence of steam, which will generate a gas relatively rich in hydrogen. And gasification in the presence of hydrogen, which will generate a gas rich in methane. And that's the basic constituent of synthetic natural gas you find in energy networks.
In Poland, the underground experiment has run for 3 weeks, and its scientists are delighted with the results. The underground reactor has converted around 50 kilos of coal per hour, and they've spotted no sign of any dangerous leakage. Researchers then took a close look at the hydrogen and other gaseous products.
This is where we analyze the different chemical compounds present in the gases created underground. We use chromatography to perform those chemical analyses. A pipeline coming directly from the reactor brings the gases to this system. The computer reads the data and displays it in graphic form, so we can easily identify the different gases produced, in this case mainly carbon dioxide, carbon monoxide, hydrogen, nitrogen, oxygen, and some pollutants like sulfur compounds.
Researchers now aim to improve the system to maximize production of hydrogen and minimize the output of dangerous byproducts, with multiple advantages in mind.
In classical coal mining, shallow, thin seams of coal are not always extracted. There's too much work involved for what you get out. But the gasification process could add economical value to the mining process and the pits themselves. Less coal would be wasted, energy output would increase, and it would be produced in a more environmentally friendly way.
The success of the project could have a double benefit, producing a clean form of energy and also maybe a second chance for Europe's struggling coal regions.